Hello. This is a fairly short topic for you, and it's one that you're probably quite familiar with already from maths, and that's motion. Motion is a very important part of, say, GCSE physics. There we'll look at speeds and velocities, accelerations, and look at how speeds change with forces, and so it'll be useful to cover a little bit of this now, so that whenever you do come across it in GCSE in year 11, that it'll be a bit more familiar to you. But as I say, you've done some of this in maths already, so what we'll do in this lesson should not be new to you whatsoever. Speed is the first thing we're thinking of. And what is speed? Well, whenever we see a speed sign in the road, what does that tell us? This is 40, it says 40 miles an hour. Well, let's think about what that means in difference. So we've got 40 miles. Well, 40 miles, what's that? That's a distance. And r, what's that? That's a time. So speed is a distance per time. In other words, how far something travels in a certain amount of time. So looking at our notes, speed is a measure of how fast something's moving. The speed of an object tells us the distance travelled in a certain amount of time. Notice I said there in a unit of time. That could be an hour, it could be a minute, it could be a second. And most of the time in physics we're going to use the distance travelled in 1 second. So if we consider a sprinter, Olympic sprinter can do a 100-metre race in about 10 seconds. So 100 metres in 10 seconds, that means on average they're covering about 10 metres every second. So they're running at a speed of 10 metres per second. And we'd write that down as 10 m/s, metres per second. The vast majority of the time in physics we will use metres per second as our unit of speed. Other units of speed can be miles per hour or kilometres per hour. They're a bit more commonly used, but metres per second is the one that we're going to be using most of the time in physics. So very simply, how do we calculate speed? We need to know the distance travelled, and we need to know the time taken to travel that distance, and we simply divide them. So as you can see here, as we cycle along on a bike, or same as we travel along in a car, our speed doesn't stay constant. It goes up a bit, it goes down a bit. So really, whenever we consider the total distance we travel and the total time taken, what we're considering is the average speed. And so to put that into a formula, average speed equals distance travelled divided by time taken. And we can shorten that to speed equals distance over time. So here's a simple example. A horse takes 12 seconds to trot a distance of 96 metres. Calculate the average speed of the horse during this part of its journey. So as is the case whenever we do any sort of calculation, we write our formula, we substitute in our numbers, we get our answer. Speed equals distance over time. Keep your equal signs lined up. The distance is 96, the time is 12. Again, line up your equal signs. 96 over 12 is 8. And because it's in metres and seconds, our unit is going to be metres per second. We skip over our notes to page 7. We can rearrange this formula for distance travelled. So if we know the time taken and we know the average speed, we can combine those back together to find the distance. And if we know that speed equals distance over time, if we multiply both sides of that equation by t, we get s times t equals d. So distance equals speed times time. Whenever we use any equation like this, we need to make sure that our units are consistent the whole way through. So if our average speed is in metres per second, we need to make sure that our time is in seconds and our distance is in metres. If we're given a time in hours or minutes, we have to convert to seconds, or if our distance is in kilometres, and so on. You need to make sure that your unit of speed matches up with your unit of distance and of time. So another quick example. girl walks an average speed of 2 meters per second for 80 seconds. How far has she walked? Formula, substitution, answer. Distance equals speed times time. Line up or equals. 2 times 80 equals 160. And no answer is valid unless you've included the unit. Speed was in speed was in meters per second. Time is in seconds, so the distance is going to be in meters. Finally, we can rearrange this for time taken. If we know distance equals speed times time, divide both sides by s, we get d over s equals t. So time equals distance divided by average speed. One real-life example of needing to make sure your units are consistent occurred a few years ago in the Republic of Ireland. The Republic of Ireland used to have all its road signs in miles and miles per hour, and then they decided to converge with European standards and change everything to kilometres and kilometres per hour. Now, you cannot change all the road signs in one country overnight, and so there were times when you had the speed signs in kilometres per hour, but the distance times still in miles, which meant that you couldn't easily say, well, I'm travelling at 30 miles an hour, or I'm travelling at 50 kilometres per hour, and my distance is 5 miles, therefore I can easily work out what time. There were extra complications involved in working out times taken. It's all been rectified now, and it just took a few years to get everything sorted, but that's why it is important to make sure that you have your units consistent. So, one more example. Ferry transports cars at an average speed of 4 meters per second. The river is 640 meters. Calculate the time. Time equals distance over speed. 640 meters divided by 4 meters per second gives us 160. And our unit must be in seconds in this case. I would tend to keep it in seconds. You could say 2 minutes and 40 seconds, but we'll just keep it in seconds. As I've mentioned, there are other units of speed, those other than meters per second. Sometimes meters per second isn't very appropriate. If we consider a snail is not going to move many meters in any second, it's going to move millimeters per second, so that might be a more useful unit. And again, for cars we don't usually use meters per second because a car will travel very, very many meters over a longer period of time. So miles per hour or kilometers per hour are usually more useful. If we do have to do calculations with different units, the formulas are identical. We just need to make sure our units are the same on both sides of the equation. So if the speed of the snail is in millimeters per second, we need to make sure our distance is measured in millimeters and the time is measured in seconds. Similarly, the car, kilometers per hour, the distance should be in kilometers, and the time is going to be measured in hours. That might mean that you have to do a conversion beforehand. So here's an example. A motorbike travelling along the motorway, distance is 186 kilometres, 2 hours, calculate the average speed, same formula. Speed equals distance over time. 186 over 2, 93, but this time it's going to be kilometres per hour. Now you'll have some questions to do yourself.